Welcome back. And the 500 watt plus journey continues. The next presentation will be given by Trina Solar. Trina was not only among the first to reach the first 500 watt threshold, it's also in the front row to master the 600 watt level. Representing Trina Solar today is its product marketing manager for Europe, Klaus Hofmeister. He has started his professional career in the semiconductor industry and has been working with solar manufacturers since 2009. So with Trina Solar, Klaus is now for over 2 years. And here he's responsible to devise effective marketing strategies for the company in Europe to help further enlarge and diversify the customer base. Klaus will talk about 550, 600 watt module Vertex series and how you can use that to further lower the LCOE. We're happy to have you, Klaus. Welcome to TaiyangNews. The floor is yours.
Thank you very much, Michael. Thanks for that kind introduction, and thanks for giving us the opportunity to use that stage on this online conference to introduce our new product range and especially our technology platform with the Vertex module series. So let me share my slides, which I will present to the audience. First, I would like to introduce myself a little bit. Michael has done already quite a lot. So my name is Klaus Hofmeister. I'm welcoming you, all the attendees here to this online conference on behalf of Trina Solar. And today, my presentation will guide you through the next generation of products we will have within Trina based on our Vertex technology platform, which is the M12 wafer technology or the 210mm solar cell size. I mean, I was following a few of the presentations already, and we hear a lot about larger scale modules and higher power per module. So I don't want to put only the focus on the module size and the module power. This is important, of course, for us, but also, let's say, the later intention behind this development of products is lowering the LCOE, means improve the cost situation overall for PV installation and bringing PV further in the climate change topic, bringing PV further also with respect to lowering costs per kilowatt hour produced. And that Trina wants to, let's say, contribute quite well with the new product generation with 550 watt modules, 600 watt modules, and we can give an outlook. There is more to come for sure. So 600 watt might not be the end of the development in this product range. All right, I want to step right into, but maybe another comment again. I mean, as you can see from the presentations, all from the latest news and announcements, if you're following developments on module types and module power, you can see that the PV industry and the PV manufacturers are split more or less into two parties. We have the WAM10 fraction, which is more or less looking into products based on the 182mm cell size. And then we have the M12, let's say, division within the PV industry, setting all their focus on the 210mm solar cell technology. And I want to give you an introduction into that. And I want to show you why we think the 210mm solar cell size and technology is the one leading the product into the future. It has been a few weeks ago, or at least it feels like for me, that Trina has announced the first 500 watt module with the Vertex series. And that really has been only a few weeks ago. I mean, it was in February when we said, okay, we're going to launch that product and we're going to start production more or less as we speak now. So the first 500 watt products are now coming out of production and from our new manufacturing line based on the 210mm solar cell size. A few months later now, I'm in the happy position to announce the next generations, 550 watt plus and the 600 watt module generation, which will come in the first half of 2021, finally in volume production. So the development really is quite steep in this industry, and I don't know really where it ends right now. There's more to come for sure. I'm quite confident about that. And also, let's say, our competitors are looking into further increasing that. But at the end, it's all about driving down costs for all of us, means for the whole value chain, to bring down system costs and also to lower the cost per kilowatt hour produced in a PV system. I want to guide you through our new products. I mean, the 500 watt module, which we announced a few weeks ago or a few months ago, was based on third cut 210 millimeter cells. We are now stepping into the new edge, let's say, of products. And that means we are not any longer using the third cut cell technology, but for the 550 and the 600 watt modules, we are using half-cut 210 millimeter cells. Other technologies like Multibusbar have been introduced already with Vertex. Non-destructive cutting, I will come to that later on in a slide, explain how cell separation works and how we increase module reliability with this new cell cutting process. We are using high density cell interconnection technology to increase module efficiency, to put the maximum active area into one module of a specific size. We've changed the layout, so we have a 5-cell by 11 layout per half of the module in this 550 watt module. Half cut, as I already mentioned, and for our double glass bifacial module generation, we are offering 30 years of warranty. You can see the dimensions of the product on this slide, the weight, and what is really, I think, a key advantage of all those high power modules which we are introducing from the 550 watt onwards is the lower module voltage, which I think is a key advantage for system designers to design long module strings until they reach the 1500 watt barrier. And that gives high flexibility in terms of system and string design, which I think is a key advantage. Maybe a slight disadvantage showing here is the high module current of 18 amps. Yeah? That is something completely new. We have to also get used to it. I mean, that's the drawback of the large cell sizes. But I was told, and let's say our communication with a lot of our partners on the engineering side was that they said, okay, we can handle those high currents in system design. The downstream components like inverters, combiner boxes, or whatever is needed to design the system properly will be adapted and established to fit to those modules. So that is something which is currently in progress. And until the modules hit the market, we will be ready to have all components fitting to a system. Then, of course, the 550 watt module is the next consecutive step after the 500 watt module. But we already have the second arrow, let's say, which we want to shoot out today, and that's the 600 watt module. It's more or less based on the same cell technology. It uses all the technological advantages I already mentioned, but it has a slightly different layout. It's a 6x10 cell matrix again in one half of the module. So that's something which is slightly different. Therefore, the module gets slightly shorter, but a little bit wider. So those two module designs don't fit in terms of its dimension, in terms of its form factor, but they all have the same advantage: low voltage, therefore the higher current to achieve the high power, and efficiency goes up on module level above 21%. And that is mono P-type PERC. This is not N-type or any other technology. So this is standard mono P-type PERC cell technology. Talking about technological innovations which are integrated in the product, multibusbar technology today is standard. We have introduced that already more than a year ago in all our standard portfolio, and now it's further adapted to the large cell size. It offers really a few advantages in terms of light capturing, in terms of heat distribution in the module. So the multibusbar technology really lowers the series resistance in the module and helps us to improve module efficiency overall. And it's also a reliability improvement within the module. So the more small, thin bus bars you have, the lower the cell to really pull down the power output of the module. So multibusbar technology is really a reliability improvement in the module technology. Non-destructive cutting, I think that's a crucial step forward within module technology, and especially also within module reliability. I mean, the conventional cell separation technology uses laser melting. So this means we are heating up the cells from the backside of the cell more than 1500 degrees in order to melt the silicon, and then to do a mechanical separation of the cell. This leaves a rough cutting edge, which might be the source of mechanical or micromechanical damages within the cell at this point where you cut the module or cut the cell, sorry. With the non-destructive cutting process, which we have developed mainly for the third cut cell, but now we are using it throughout the whole Vertex and 210mm cell technology, is low temperature. So we are not going to the melting point of silicon, and we are trying to make this cutting as smooth as possible. So here on the picture, you can see the smooth cutting edge. There are no structural micro damages in this cutting edge, which can at the end be the starting point for micro cracks during mechanical load testing or during the mechanical use and stress seen in the real application when a module is installed. Unfortunately, I can't talk more about this non-destructive cutting process because it's really a secret within Trina and the Trina organization. It's something we have developed, and we have also, let's say, brought to volume production, and we are very proud to announce it. And at the end, it's really, really for the benefit of the customer that he gets a highly reliable module, which he has happy about to have it for a long lifetime of 30 years, or maybe even beyond that. Other than that, I think what we really used, or what we really want to promote, is the high density cell interconnect technology. I know we are not the first ones to announce it, and you probably might see it in several presentations today when products of this type are getting presented. But I want to emphasize again why we are using this technology and why we are not using, for example, the overlapping technology or shingling technology, which some of our competitors might use. The traditional cell technology on the top left corner is that you have a cell gap of 2 millimeters or even above that. I mean, therefore, you have quite a lot of cell space or space on the module which is not used by active area. On the very right side, on the top, you have the overlapping technology or shingling technology, which from our perspective at the moment is not mature and reliable enough in order to be used for products which should last for 30 years at least. Yeah. So this means also, and let's say when you overlap cells, that you also waste active area from the cells. So in terms of yield, this could be also a disadvantage because really active cell area is wasted by the overlapping technology. So from our perspective, the best balance between module efficiency and module yield means utilizing the most of the active area a cell is offering best is the high density encapsulation or cell interconnect technology. That means we are reducing the cell gap from one to the next one down to 0.5 millimeter or even below with conventional solder joints. From our perspective, that is the most reliable and mature technology. And this is also, let's say, a significant step forward to increase module efficiency. And we will use that more and more in our product portfolio, and especially for this high power, large scale, highly reliability modules, we introduce this technology on a broad product portfolio. Of course, the new power generation of modules should not only be reliable, but it should also be flexible in terms of its installation opportunities. We will go all the way and test our modules to the IEC standards. We want to achieve maximum loads in certain clamping and mounting areas of the module. We are also, let's say, evaluating all kind of trackers, single axis trackers, which are available in the market. We are also using our own tracking solution, which we have in the Trina product portfolio. So those modules are really produced, designed, and manufactured and developed for maximum flexibility in terms of usage. So the customer, of course, when you need more information, more details on that, please don't hesitate to contact us. We can help you out whenever you have specific mounting requirements or you need some feedback on how to utilize the modules best. Trina will certainly help you and support you to find the best solution for you. Then I want to look more into this LCOE topic and the economical comparison. Yeah, we have here some reference modules, and I mentioned really the battle is between M10 and M12 technology right now. So we have the 182mm cell products which are competing with the Trina Vertex series with the 210mm cell technology. Here you have a one-to-one comparison in the different power classes we are actually having out there in the market, which are already announced by some of our market competitors. Where I see the clear difference between the 182 module generation and the 210mm Trina Vertex series is the lower voltage of the Vertex modules, which really offers higher flexibility, longer strings, more power per string, less string cabling. So overall, I think this is the right step towards lowering LCOE, but also towards lowering balance of system costs. So yeah, the higher current might be a drawback for now, but I think that is easier to handle, and that's also the feedback we have received from partners. They have calculated our modules versus 182 cell modules already in some of the systems. They have done the design, so we can prove that this is a cost benefit for the 210mm cell technology on the BOS side, but also at the end on the LCOE side. Here we go with a slight comparison, what I already mentioned. It's the flexibility of the string length. And when I use a 210 module Vertex with 600 watt, and I have to compare it with the reference module based on M10 technology, we have simply the fact that with 600 watt modules from Trina, you can have a 33 module string, while the reference module only allows string lengths up to 24 modules. And this is for 1500 volt maximum system voltage at -10°C outside temperature. This is the system design. So we have almost 20 kilowatt per module string with the Trina 600 watt module versus a 14 kilowatt string power for the reference module. This is one advantage, and the next, let's say, advantage you can see here when it comes to the mounting topic. So mounting 33 modules, and let's say you overall will save money, and let's say also mounting structure means real steel, real rails when you calculate a project. So for the 600 watt module, we have less, or we need less piling to mount a megawatt versus the reference module of 585 watt. And that already, I mean, it's easy to calculate, will provide you a cost benefit on the long run. Also considering the amount of steel which is used for that. So per megawatt, we can save around about 7 tons of steel when we are using the 600 watt module versus the reference module on M10 technology. And of course, due to the fact that you have less strings per megawatt, we can also save cabling. And I think the question which might come up is, yeah, you have higher currents, you might use thicker cables, you might need higher diameters. I mean, we have been through this calculation already with some of our partners also, and they all told me, or let's say the feedback was quite clear. We can still of course, depending on the system design, we can still use 4 square millimeter or maximum 6 square millimeter cables, even for the high current modules of 600 watt. So from that perspective, I would say on a system design side, there is not much to change, and the 600 watt modules can be relatively easy adapted to existing system designs, and also using the downstream equipment like inverters, who will be adapted also right now to this module generation. So at the end, I would say really there is quite a cost benefit for this module generation and for this technology platform. Here then again an overview in terms of BOS cost, and I just want to emphasize and mention, please don't take all these numbers for absolute and for granted. Yeah, this is for a specific project, and this calculation is done for a specific location. Yeah, the numbers might change depending on your project, on your mounting situation, on your ground, or wherever you want to put the modules. Yeah, but in general, what is clearly visible is that the cost structure is in favor of the 600 watt high power module based on 210 millimeter technology, and we will be able to lower LCOE in the range of 2 to 3% with that module generation. And I think that should wake up a lot of our let's say customers and those who are really designing systems. This is a number, I think, which is worth looking into it. And therefore we expect that this product technology and this product generation will really be successful and hit the market at the right time. So Trina is ready for this product generation. We are willing to, let's say, help out wherever we can. So whenever you're interested in, please feel free to get in touch with us to get more details and more insight onto these products. What is really, let's say, changing on the system design side? I have to say there's not much which really changes. Yeah? On the AC side, this is a system layout for a central inverter, so, the system design. There's not much changing in terms of the DC side. Of course, you have longer strings, you have higher currents to cope with, therefore a few of the components might need to be adapted. But as I already mentioned, the cable diameters, for example, there's not much you have to increase or to change. Yeah, I mean, of course, higher current, you might have higher losses in the cabling, but still the calculations show that it's within a range which is acceptable for most of the system designers. So here, not much to adapt from your side. And the same more or less applies when you're using string inverters on a larger scale system. So the AC side is not influenced by the high power modules or by this new module technology. On the DC side, we have to, of course, work with the inverter suppliers to adapt their inverters and their equipment to this high currents. That's currently going on. So all the top players in the inverter market are adapting their devices to fit to this high current modules. And when that has happened, I think we are ready to go. And there's nothing standing between the module and the system in order to prevent that this is not, that we are not able to handle it. Yeah. So even from that perspective, the market will be ready when the module are available on the market. Other than that, we are of course trying to be as flexible as possible with all the different mounting variations and options. Tracker systems are really in the focus of those high power modules because they are also, let's say, first of all, highly important for some of the real large scale projects in different areas in this world. But also Trina is of course offering its own tracking solution, which is here the top one with Enclave. And we are really optimizing our tracker for this module generation, mainly also for the use of bifacial modules with our trackers. So there is a lot going on. We are also, let's say, trying to make sure that we are compatible with all the major tracker manufacturers in this world with our products, and we are in direct and strong contact with them in order to make sure our products or their products are ready for our modules on the long run. And please stay tuned with us. Just also, let's say, get in touch with us if you want to know anything further about the combination of Trina's Vertex series together with any tracker solution, we can certainly help you out to make the best use out of this combination. What are our capacity plans for those products? Yeah, there's quite a really, let's say, yeah, I would say extreme growth predicted and let's say also wanted within Trina. So for 2020, we forecast a 10 gigawatt production capacity for overall 210 millimeter product technology. So it means also 550 watt modules and 600 watt modules. So in Q4, we already start with a volume production of the 550 watt module. And in this is an error here in this slide. In Q1 2021, we want to start with a 600 watt module production. So I expect availability by middle of next year of the 600 watt module in the market. 2021, we want to grow up to 21 gigawatts production capacity, and 2022, we are going up to 31 gigawatts of production capacity for the 210 millimeter technology. This is quite a steep ramp from our perspective, but we also expect that this technology will be leading the whole PV industry into the future. I expect even those who are now, let's say, putting all the focus on the M10 technology will sooner or later switch over to 210 millimeter, because on the cost side, I'm quite sure it is really a benefit to use this larger scale cells. A small summary again at the end of this presentation before we go into the question and answer session. Of course, yeah, we have announced the high power modules 2 weeks ago, officially globally from our headquarters. Now we are more or less on the run to get this introduced into volume production. The concept is low voltage, means high string length flexibility, but higher current therefore. But I already explained this will be, or we will be able to handle that. This means high string power when you connect a lot of modules into one string. We are exceeding module efficiency of 21% with both products. The layout is completely new, so the module dimensions are different to M10 wafer products and to existing products, which we all know, based on 72 cells or so. Then we want to clearly focus on lowering BOS and LCOE. This is beside, let's say, the larger products and their new technology, the key focus of this product. We introduced the 210 millimeter wafer and cell technology as the leading technology for the future. And our key focus also is, and that's why Trina also formed an alliance with downstream equipment manufacturers to be compatible with all the mainstream system design equipment. And that is also, let's say, more or less established right now to be ready whenever the modules are available. That's it from Trina's side with respect to the new products, the new generation, the new Trina Vertex series with our new technology platform. I'd like to thank you for watching and listening to us. I hope there's something in it for you, and I'm open and ready for the discussion on this interesting product platform.
Thanks, Klaus. For me, it was very interesting and very impressive. Also to see your growth plans, amazing. So I think that's what we need, the planet needs. We need more solar, we need it faster, and that's the right way to go. Let's maybe talk about, or just start maybe the Q&A from my side also. What you said actually that you don't see the end of the growth phase, although it has been very steep in the last few weeks almost. What can we expect? So I don't know if you've seen Charlie Gay's presentation in the morning, the keynote. He showed a solar module that Solon once designed, you know, in the heydays, the first gold rush in Spain, when feed-in tariffs were super high, and you could didn't have to look so much at cost. You had this 2-axis trackers, and they had this 1 kilowatt modules. where are we going, and what do you see in terms of module size? Because size is the limiting factor, as we've heard several times today. We have the containers. We have we have simply limits.
Yeah, there are limitations definitely on the production side as well. So production equipment is of course also a limiting factor, but also availability of some of the components like glasses at the moment is something, let's say, which limits the size. But I mean, in terms of power development, I expect definitely that we will see even higher power modules going up to 650, 660 or 700 watts. Yeah, I'm not really sure if there will be or where will be the end, to be honest. It's very difficult to predict from today's perspective. Yeah? But I'm quite confident that we are not at the end of this development. And yeah, the key focus is also further lowering LCOE. And for that reason, all the module manufacturers would look into new module designs, new cell technologies, maybe even larger cells than 210 millimeters. So there is some space for development, for further technological improvement, and maybe also, let's say, not only in terms of growing in size, but also, let's say, in terms of increasing efficiency. This means not only on module level, but also on cell level. Not only due to new technologies, maybe heterojunction or N-type, but also improving the P-type PERC technology further. So yeah, there are a few screws which we can fine tune, and I think this development will continue. Yeah. For sure.
Okay. So because you really mentioned that you could imagine even larger cells than M12.
Yep. I think there's a possibility from a technological point of view to even increase above the 210 millimeter. Yeah? I think we are looking already into that, and I hope that there is, this could be successful on the long run, and therefore I expect that module power we will see modules going up to 700 watts. So I think there is an opportunity out there, and as soon as we are able to manufacture that properly, it will be started and launched.
Okay. So I think there's a couple of questions. Commercial production availability roadmap for these modules. You mentioned that, I believe, but maybe you can repeat it once again.
I can repeat it. I mean, we are starting the 500 watt production as we speak right now. Yeah, this is currently coming out of production. So we have started in July with volume production. The 550 watt module series will be started in end of this year. So I expect Q4, December timeframe, we will start the 550 watt module volume production. And beginning of next year, either Q1 or Q2, we will have the 600 watt module in volume production.
Okay. I think there's also one question, actually, again, to really understand this change in trends, so that in the past it was rather high VOC and lower currents, and now it's shifting the other way around. Can you maybe elaborate on that once again?
Yeah, this is definitely a kind of paradigm change, because I mean, of course, with the half-cut cell technology, everybody wanted to lower the module internal currents, lowering the resistive losses. But I mean, we had to decide whether we go with even higher module voltage to achieve the 550 volt. This would have meant shorter string lengths, less flexibility in terms of system design. And that is something I think we didn't want to go down the road. So for us, the decision was relatively clear. We can cope and handle the higher currents, which are coming with that module generation of 18 to 19 amps. Yeah? But therefore, we are going down with the voltage. And the lower voltage really gives the advantage, because it really increases flexibility. You have more power per string. And I think that is something which the engineers are liking more than, for example, high voltage modules with lower power. I think there's from a system design perspective the preference.
Okay. I just recently, that's maybe also from my side, so I recently talked to one tracker manufacturer, and he kind of really said, oh my God, all these big modules, and they're all different, and so we really have to adapt that, and it's often anyways. So customer specific when we are at the sites, and so that means we have to adapt again. And then there's the wind loads. As you also produce trackers and do it in-house, so what has been your experience so far with this large modules? I think you probably did some testing with in-house system.
Yep. Yeah, we are currently in the phase to also redesign our tracker solution for this module types. I mean, this larger scale modules really are a challenge, and I have to admit we have to adapt all our tracking solutions to this size of modules. Yeah, that's the drawback of it. But at the end, I mean, once the solution is up and running and set up, yeah, we can really harvest the cost benefit of this solution. It is, of course, mechanically these modules are a challenge, and everybody who is wants to use it on trackers has to do some recalculation, maybe some adaptation in their tracking, but also for fixed tilt, this means probably new design rules. So at the end, all the systems will have to be adapted, but I think that's worth it, because at the end, when it comes to overall system cost, it's worth it, and it's a positive, let's say, factor for lowering the cost side.
Here's also one interesting thing. So regarding safety, I think we haven't touched upon that. So high string power is obviously also considered a safety risk. So what do you recommend taking into account when designing a system with 600-watt modules?
Well, from a safety perspective, I'm not sure what the question is really relating to, because I mean, we have the boundary conditions within the string. We have 1,500 volts, independent if you use a 600-watt module or a 300-watt module. Yeah, so we are going to that edge anyhow. The higher currents are, let's say, more or less a challenge. So we need to make sure that we have to use the right cable diameters in order to keep the losses low. Other than that, I would say there's not much more risk involved in those products than in any other currently existing product at all. Yeah, the string power itself is not really visible in terms of additional safety or precautions we have to take out.
Okay, while some of your competitors have also bifacial or shown larger bifacial modules, you are focusing on monofacial. What's the strategy?
I really forgot to mention that, yeah. But all our Vertex products are available as monofacial glass backsheet modules with frame around it, and the second let's say product derivative we have from each of them is the dual glass bifacial with frame around it. So those are the two products we are offering for all the watt classes I have just highlighted. So Trina is going that way. So dual glass will be bifacial, and glass backsheet is a monofacial product, and you can have it for both generations, 550 and 600 watt. So both versions are available.
Okay, that's good to know.
That's a keynote which I forgot, something really essential.
How are you looking at this trend to gallium doping? So we've seen JA showing that. I think others are also jumping on that. That boat. Is it?
Trina has jumped on that as well. I think that's something which is not really new in the industry, and nobody is hiding that. Trina is on that as well. So we have adapted our warranty conditions, especially also for the newer generations of products. So we have reduced first-year degradation in the warranty to 2% maximum for all our products. This means we are also using gallium-doped wafers. So yeah, I think the industry here is more or less on one page. We are all looking into the same technology enablers in that sense.
Okay, I think that's good to know. Can you maybe, I think Trina is also, are you part of this second group? There's because I think JA mentioned also that there is this 182 millimeter group, so the M10 group, and there's also, I think, a G12 group. Is Trina part of that, or?
Yeah, I think Trina is one of the initiators of that group, and due to the, let's say, during the official launch event with the Trina Vertex 550 and 600W module, this group has been in a stage discussion, and all of the representatives of this group have been present. So this can be viewed also on, I think it's available on social media as well. So Trina is definitely one of the initiators of that group, because we want to make sure that this technology really makes the way into the market by providing all the downstream equipment which is needed to do a proper system design. And yeah, therefore we are also part of this group as well.
Okay. Is there anything else? Yeah, I think maybe we've seen you're also dramatically expanding also on the module side. I think your strategy is also somewhat different than other companies. I think maybe one could also differentiate that the 182 fractions are the more vertically integrated company, while Trina is more focusing on cell module levels. So what's your take on wafers? Will you rely more on external wafers, or is there also an idea at some point to kind of at least somewhat match your module or cell capacities?
I mean, starting now with this 210 millimeter M12 wafer size, we are definitely have to focus on external wafer supply right now. On the long run, I'm not sure if we really want to go into that arena to produce our own wafers. I mean, that's more or less basically a decision which has to be driven on headquarter level. Yeah, so this is something which we can't drive out of the region. But at the moment, the technology is really based on external wafer supply for the 210 millimeter technology. Yeah, and that seems to work out quite well. Yeah, I think we are not competing here with our main competitors in the market.
Okay. I think that's. Or maybe there's one more question regarding this gallium doping. Have you also this license from Shin-Etsu? Can you reveal that, or is there because I think at least the JA pointed that out, that they have that, and I think Longji also did that, or.
Honestly speaking, is a question I can't answer out of my head.
Okay, yeah, no worries. I know. Okay, that's okay. But you are doing it, so yeah, no, I think
yeah, we are doing it. I assume we have it, because I think we are definitely on the right side, on the legal side of this, and
that's what I would imagine. I don't know if there's other ways of doing that, but so in any case,
that's
okay,
out of my knowledge right now, to be sorry.
Yeah,
but I could maybe answer that questions and at the later stage.
Okay, thanks again, Klaus, for this great presentation, all this
Thank you very much.
Insights you've given, and thanks so much. Have a nice day, and
thank you. You too.
Again,
enjoy the conference, everybody. Thanks.
Thank you.